Hey everyone, so I wanted to show you a couple examples of using conditional probability when given a word problem and the two-way table is not created for you. Now, that doesn't mean every problem is going to require you to make a two-way frequency table. It's not, but it also gives you a good visual for the ones that definitely do or might make it a little easier for you. In any case, here we go. Of the 30 students in Mrs. Smith's math class, 13 are athletes and 9 are in band. 3 of the athletes are also in band. If one student is chosen at random, find the probability that this student is in band if it is known that they are not an athlete. So our table needs to compare those that are athletes versus those that are not athletes, along with those that are in band and those that are not in band. So essentially, here's what it should look like. We want to fill in the parts that we know. We know that there's a total of 30 students, so that would go in our total column and row. We know that 13 are athletes, so that should go in the column for our total of athletes, and 9 are in band, so that would be the row for band, total of 9. We also know that 3 of the athletes are also in band. So where athlete and band meet, we would have 3. We'll come back to the question in a little bit. Let's finish filling in this table. There's many ways to begin, but we're essentially going to either add or subtract parts in your rows or columns to get the rest of them. So we can find that we have 10 that are not in band but are an athlete by subtracting 13 and 3. We can find that there are 6 that are in band that not an athlete by subtracting 9 and 3. 21 from 30 minus 9. I think you get the idea. So here's our table. So now let's go back to the question. If one student is chosen at random, find the probability that this student is in band if it is known that they are not an athlete. So you want to find where they overlap. You want to find the number of students that are in band if you know they are not an athlete. Find the overlap. So there are 6 students in band that are not considered an athlete. That'll be your numerator. Now, the denominator would be represented by if it is known that they are not an athlete. So that's your total for not an athlete. Therefore, the probability of being in band, given that they're not an athlete, is 6 out of 17. Next question, same idea. Out of 125 children at summer camp, 45 signed up for swimming and 38 signed up for arts and crafts. 12 students who signed up for swimming also signed up for arts and crafts. If a child is randomly selected, what is the probability that they are signed up for swimming if it is known that they did not sign up for arts and crafts? So our table needs to compare those that are in swimming versus not in swimming, and those that signed up for arts and crafts versus not signed up for arts and crafts. So again, it should look like this, similar to our last one. Let's fill in the parts that we know. We know the total. We know 45 are signed up for swimming, 38 are signed up for arts and crafts. We also know that 12 of them are doing both. Therefore, the same way we filled in our last table, just subtract your parts to fill in the missing pieces. So we can have 26. It doesn't matter the order that you go, but essentially, here's our table. So now the question is, what is the probability that they are signed up for swimming if it is known that they did not sign up for arts and crafts? So we're finding the probability that they swim given that they are not in arts and crafts. First thing you need to do, find where they overlap. Find where they are swimming but not in art. So that would be 33. And there's our numerator. Our denominator would be if it's known that they did not sign up for art. So that would be the total of those that are not in art. That would be 87. Therefore, your conditional probability is 33 out of 87. If you have any questions, let us know. Bye.